In this section, we will learn how to calculate the atom economy. Chemical companies will use reactions to make the products that they sell. And of course, they want to use reactions with high percentage yields. In addition to that, they want to make less waste. So they want to produce as much of the product as possible from the reactants. Chemical companies try to use reactions that waste as little energy and raw materials as possible. Financially, this will help the company make money. And it's better for the environment too, as it conserves limited resources, so less resources are wasted, and this will reduce the pollution as well. From this perspective, the term atom economy emerged. The atom economy of a reaction is a measure of the extent to which the atoms in the starting materials, which are the reactant, end up in the desired product. So we know that reactants will react to produce the products. The atom economy is the extent to which the atoms of the reactants will be in the desired product. This is the mathematical expression of the percentage atom economy. It's equal to the relative formula mass of the desired product from equation, so MR, of the desired product, the product that the company wants to sell, divided by the sum of the relative formula masses of the reactants from equation. So we will add the relative formula masses of all the reactants times 100%. So again, the percentage atom economy is equal to the relative formula mass of the desired product from equation divided by the sum of the relative formula masses of the reactants from equation times 100%. This is the reaction of the production of ammonia, NH3. In this reaction, all the atoms in the reactants, so we have 2 nitrogen atoms and 6 hydrogen atoms, appear in the products. So on the product side, we have 2 nitrogen atoms and 6 hydrogen atoms. And this is an example of the ideal 100% atom economy. As you can notice, this reaction is a reversible reaction. And this means that any reactants emerging from the reaction vessel, because they haven't reacted yet or they reformed from the product, will be continuously recycled back into the vessel. And in this way, no reactants are lost. Let's solve this example. When lead is extracted from its ore, which is called galena, the first stage is the roasting of lead sulfide, PbS, to convert it to lead oxide, PbO. The lead oxide is then reduced to form lead metal in the next stages. The balanced symbol equation for the first stage with the state symbols is 2 lead sulfide, PbS, which is solid, plus 3O2, which is gas, will produce 2 lead oxide, which is solid, PbO, plus 2SO2 gas, sulfur dioxide gas. We have to calculate the percentage atom economy of this first stage in the process of extracting lead. We are given the relative atomic masses of lead, sulfur, and oxygen. Let's start with writing the mathematical expression of the percentage atom economy. So, the percentage atom economy is equal to the relative formula mass of the desired product. In this case, the desired product is lead oxide, divided by the sum of the relative formula masses of the reactants from equation, times 100%. What are the reactants in this equation? Excellent. They are lead sulfide and oxygen gas. Please pay attention to the stoichiometric coefficients. Let's now find the relative formula masses of the desired product and the reactants. So the percentage atom economy is equal to the relative formula mass of lead oxide. Pay attention that we will multiply by 2 because the stoichiometric coefficient in the balanced equation is 2. Divided by the relative formula mass of lead sulfide, again we will multiply by 2, which is the stoichiometric coefficient. plus the relative molecular mass of oxygen gas times 3 times 100%. So here we have 2 times 207, which is the relative atomic mass of lead, plus 16, divided by 2 times 207 plus 32. 32 is the relative atomic mass of sulfur, plus 3 times 2 times 16, because we have O2 molecule, times 100, and thus we have 446 divided by 478 plus 96 times 100%, which is equal to 77.7%. So the percentage atomic economy of the first stage in extracting lead is 77.7%. The other product of this reaction is sulfur dioxide gas, and this gas is a serious pollution threat. Why? Because it causes acid rain. So companies have to find a way to remove it from waste gases.